Okay, so for this question, we're looking at our critical numbers. So my first step is going to be to look at the domain. And you guys, when you're thinking about the domain, I always like to think about it as, is there a problem? And I know that sounds kind of bad to be like, is there a problem or not? But the problems are going to be denominators and square roots. So if I have a question that has a denominator or a square root, then I get all stressed out about it and I say, okay, like the denominator cannot be 0 or the radicand needs to be positive. But those are my problems, denominators and square roots. When you look at this function, you see that it does not have a denominator and it doesn't have a square root. That means that the domain is all real numbers. So you can just write all reals. And basically, we are problem free here. So whatever number we find is definitely going to be interior inside of that real number line. All right, so that is step 1. Now, step 2 is the second part of the critical number definition. The second part of the critical number definition is that derivative equal to 0 or the derivative does not exist. So what I'll do is I'll take this derivative. So I bring down the 3. Keep in mind that this 3 in the denominator is a coefficient, so it will just carry along. So it will just tag along as a 3 in the denominator. Then our minus x squared, we bring down the exponent, subtract 1, and then the 3x is a linear term, so that is going to go to the coefficient. All right, so then we clean this up. We have that the 3's cancel out. That's very nice for us. So we have x squared minus 2x minus 3. Now, that's step 1 of finding the critical numbers here. Then we need to set the numerator equal to 0. So where the derivative is equal to 0 amounts to where is the numerator equal to 0. And that's because if you have that okay, it is just equal to 0. So when you're looking at where is the derivative equal to 0, you're really just asking yourself, where is the numerator equal to 0? Now, we also have to consider where the derivative does not exist. You will notice for this question, there is not going to be a consideration here because we have no denominator. So when our derivative does not exist, that would be when we have a 0 in the denominator. So that no means that we have our 0 in the denominator, so it's undefined. So what this means is that you don't have to worry about the second condition when there's no denominator. So if there's no denominator, you don't have to worry about this. You would just focus on where is the numerator equal to 0. Now, to solve this, so what we did is we took our derivative, we set the numerator equal to 0. We said to ourselves we don't have to worry about the denominator because there's no denominator. And now we need to solve this numerator equal to 0. Now, here is where you're going to see a lot of variety in the different types of questions in terms of can you factor it, can you set it equal to 0. So what I encourage you to do is remember that this is a square power. That is a quadratic equation. And how do we solve quadratic equations? We have our different methods, right? We have like factoring, quadratic formula, and so on. So here in this section especially, almost all of them, it would be weird if you couldn't factor it. So like, yes, you have the quadratic formula, but a lot of times this setting the derivative equal to 0 is going to amount to just needing to factor. All right, so be prepared to factor, and specifically if you see a quadratic, that's when you're going to need to factor. All right, so we have to remember all of our factoring fun here. Remember, when you have 3 terms, the first thing you do is you ask yourself, do I have a GCF? And I don't. Then you ask yourself, okay, the factors of the first times the last, so that would be factors of -3 that add up to -2. And playing around with that, it would be -3 and +1. They would multiply together to give me -3, add together to give us -2. So this would factor as x minus 3 and x plus 1. Notice because it is 1x squared, I do not need to do the whole split up into two, split the middle. I can just write it as x and x. All right, so I have x minus 3 times x plus 1 equal to 0. To solve that equation, I simply set x minus 3 equal to 0 and x plus 1 equal to 0. So adding 3 to both sides gives us x is equal to 3. And subtracting 1 from both sides gives us x equals -1. Now, it's not enough to just set the derivative equal to 0. We have to double check that this critical number is interior to the domain. Now, for this particular question, our domain is the real number system. It goes from negative to positive infinity. So every number, 3, -1, all those numbers will be inside of that real number system. So we just make a note that yes, these are interior, they're inside the real number system. And so that tells us that our critical numbers are x equals 3, x equals -1. And I always abbreviate critical number with CN. So in this section, you're going to see a lot of CN notation, and that represents the shorthand for critical numbers. Okay, and of course on the homework software, you'll just type in 3, -1. You don't have to put the X. That's important to note. You will just say 3, -1.